Okay, now finishing up for where we left off with part one, here's a couple examples that we covered today in class, and we're going to start with the square root of 20. And when we look at the square root of 20, remember that we want to look at the factors of 20. So we know that we have 1 and 20, we know that we have 2 and 10, but neither one of those satisfy us with a perfect square, so it's not going to give us any type of advantage to simplify. So we look at 4 and 5, and we can see right away the square root of 4 is going to be a perfect square. So we're going to use the square root of 4 times the square root of 5, and we're going to look to simplify this. So the square root of 4 is going to become 2, and then the square root of 5 is going to stay the same. So we get 2 to the square root of 5 in terms of our simplified answer. So we can look at that from that standpoint. Looking at example 3, we have 54 x to the fourth, and so we have an exponent here with a variable, and we're going to do the same thing as we did before. We can look at the square root of 54 as being 27 times the square root of 2 times the square root of x to the fourth. Okay, the square root of 27 times 2, we can look at this as being the square root of 9 times 3. The square root of 2, and then the square root of x to the fourth. So now we've broken things down in terms of something that we can factor out. So we've got the square root of 9 being 3. The square root of 3 and 2 is still going to give us 6. And the square root of x to the fourth is going to be x to the second power. So I can go back here, and I want to make sure that I factor out that x to the second power. So x to the second times 6. And that would be our simplified version. 3x squared times x to the 6. Now you notice there that I used 27 and 2. And I was still able to get to that answer. Had I gone right at the beginning with the square root of 9 times 6 as its factors, I would have gotten there a little bit faster. And you can see it still works the same way. 3, x to the fourth would be x to the second. The square root of 6 would stay square root of 6. So either way, we're going to get there. The other examples that we have on this page deal with that of division. So the quotient of 7 over 81, we want to look at this as being the square root of 7 divided by the square root of 81. 7 is going to stay the same. 81 is going to become 9. We can see that we don't have, following our rules, the 7 is not going to be able to find a square root, so that's going to be our simplified version. And we can kind of go back and think about the rules that we talked about. The radicand has no perfect square factors other than 1. Well, that's true because the radicand's 7. We know that the radicand has no fractions. That's also true because it's 7. And we know that there are no square roots in the denominator. That's true because we just have the number 9. So we can do this, and we'll go and let's do the number 6. 9x to the 8th over 25y to the 6th. We have nice, easy numbers to work with the 8 and the 6 as our exponents, and 9 and 25. So we can say the square root of 9 is going to be 3. The square root of x to the 8th would be x to the 4th. So that's done on top. The square root of 25 is going to be 5, and the square root of y to the 6th would be y to the 3rd. So that would be our simplified version, 3x to the 4th over 5y to the 3rd. So there's some more examples of the things we did in class today, and hopefully it helps answer any questions. If you have more, please let me know tomorrow in class. Goodbye.